Okay, so looking at the slant asymptote problem, we find the slant asymptote through long division. So we want to find, in this case, the vertical asymptote is going to be at x plus 1. But what we can do is, if I want to know how this graph is behaving as x gets really large, or endpoint behavior, what we can do then is we can do division on here. So we know that this expression here is equivalent to the quotient plus the remainder over divisor when I divide this. So if I do division here, x plus 1 into 2x squared plus 5x minus 1, I know I can put it into 2x times, and then I do plus 3. I'm going to end up with 3x plus 3. Okay, and then remainder is negative 4. So I end up with 2x plus 3 as my quotient, remainder negative 4 divided by the divisor x plus 1. So if I take a look at this graph and ask what's the limit as x gets really, really big? Well, what's going to happen to this ratio, this negative 4 over x plus 1? This essentially becomes 0. And this graph starts to behave like 2x plus 3. So this line here, I'll just highlight here, this line here, so this slant asymptote is going to be 2x plus 3. So the graph is going to tend towards that at the end. So it's not doing that near as local behavior here. But as x gets really, really large, it's going to start following that slant line. Okay? And that's how we can find slant asymptotes. Typically, we can find the slant asymptote, know that there's a slant asymptote, when the degree of the numerator is 1 higher than the degree of the denominator. So when we divide, we end up with this linear function, which as we let x go to infinity, we know we're going to be left with that linear function. Okay, so when the degree is 1 higher, 1 greater than the denominator, we end up with a slant asymptote. So here it would be an example where we have slant asymptote. Okay, so when I graph that, this is how I would approach this graph. So first of all, we're going to look at the vertical asymptote. Okay, that would be the easiest part. So there's my vertical asymptote. I want to work out my zeros of this function, if there are any zeros, so I can solve that equation. Okay, so actually, we're going to not worry about the zeros at this point, but if I want to find the zeros, I can solve that quadratic equation in the numerator. I can easily get my y-intercept by plugging in zeros, so I'm going to do that. So I have y-intercept at negative 1. I do my division like I did up here to get my slant asymptote, so that the quotient is my slant asymptote. So I have a slope of 2. Okay, and it crosses at 3, so it's going to be something that looks like that. Okay, so I know the graph's going to go through that point. It's going to follow the asymptote, okay, like that, and we're going to be able to follow the asymptote along here. And there are 2 zeros here, one here and one here, and those would be the solutions. Maybe I'll do that in red. Okay, the solution to that quadratic equation then represents the zeros of that function. For now, we're just kind of focusing on finding that slant line, though. Okay, that slant line we find by long division. If I take a look at this one here, this one looks like it's going to have slant asymptote because the degree in the numerator is degree 3, the degree in the denominator is degree 2. So we kind of think, well, maybe there is a slant asymptote here. So we can first of all kind of look at this. We know that those factors are going to cancel out, so there's holes there. So at x equals 3, there's going to be a hole. I need to factor that to get a full idea of what this looks like. So when I factor this expression, 3x squared plus 5x minus 2, I'm just going to do my box method of factoring here. Okay, I know this diagonal is equal to negative 6x squared. So I know this other diagonal also has to multiply to negative 6x squared, but add to positive 5. So I'm going to use 6, negative 1. So that's going to multiply to negative 6x squared. This will add to positive 5x. Okay, so then I factor the greatest common factor this way. The greatest common factor this way is going to be -1. Greatest common factor this way is x. The greatest common factor this way is 2. So my factored form is going to look like this. 3x minus 1, x plus 2, x minus 3, which is going to cancel out, x plus 2, x minus 3. Well, these are going to all cancel out. Really what I'm going to be left with is, this is actually a linear function, because I don't have a vertical asymptote because everything cancels. So 3x minus 1 means I have a slope of 3 going through that -1 coordinate, and I'm going to have a hole at +3, and I'm going to have a hole at -3. So that's what the graph's going to look like. Lastly, if I look at this one here, I'm again first going to start with the denominator. This one doesn't have a 0 in the denominator though, so there's no vertical asymptote here. Okay, so what's happening here? Well, let's start analyzing this. So no vertical asymptote. Let's look at endpoint behavior. So limit as x goes to infinity of f of x. We know that's the denominator is bigger, so it's going to tend towards 0. In fact, the same is true as it goes to -infinity. So we know there's a horizontal asymptote here. So that's the endpoint behavior. What about zeros? Well, if I look at the numerator gives me a 0 at 1. Okay, so I know it crosses the x-axis there. The only other point that I can get, and maybe I'll put this in a table of values here, at x equals 1, y equals 0, we also can find the y-intercept. When x equals 0, y equals -1/4 by plugging it in. So I know it's going to be some point over here, -1/4. Okay, so I know it's going to go through the 0. Okay, it's going to have an asymptote at 0. So something's got to happen here. It's got to go through those points, but then it's got to at some point come back down and follow that asymptote. The same thing's going to happen here. It's going to at some point it's got to come back down and go through there. Okay, it's got to go back to the 0. In fact, we can actually see that it's going to 0 from the negative side, because as it approaches -infinity, okay, where this is going to be negative divided by positive, so it's approaching from the negative side. As it approaches positive infinity, it's going to be a positive over positive, so it's going to approach it from the positive y value side. The graph should look something like this. So we'll look at what these graphs look like on Desmos. Okay, so just reminding, these are 3 graphs that we're going to look at. This one's the slant asymptote. This one ends up being what we expected, a slant asymptote, but actually not only was it slant, well, it's not an asymptote. Slant asymptote actually becomes the actual line of the equation because everything cancels and there's no vertical asymptote there. And this is where we have no vertical asymptote because that quadratic never equals to 0. So we'll look at the graphs on Desmos.